to our special day. And Paul is the Managing Director at Barbor Carbon and Adjunct Associate Professor at Murdoch University. Thank you for making the effort to come up. It's really special you could come. Qualifying with a PhD in forest pathology in 2005, and around the same time discovering the power of remote sensing, he saw the potential of combining these two areas of expertise. Paul gets a great deal of satisfaction in diagnosing complex health disorders in trees and finding innovative solutions for their management. This, no doubt, falls within the job description of tree hugger and tree nerd, used by his two children, Luke and Grace. Welcome, Paul.
Okay, it's a real pleasure to be here. It's great to see such a fantastic turnout today. Some really dire messages, I think, about what's going on through the wheat belt, and I agree it seems to have got a lot worse in the last 5 years. And I'll talk to you today a bit about a project that I've been involved in about 5 years ago. But it's great to be here, and great that Rachel and the team could organise. I know how much is involved in organising these events, and it's a fantastic turnout. So thanks very much. I met Rachel probably about 5 years ago now, I think, and I'll talk a bit about that story today. So I'm going to talk about monitoring and managing rail reserve vegetation condition. Rachel pretty much gave me an open slate. She said, talk about whatever you want, and I thought I'd tell you this story. And as a forest pathologist, I often get called in to diagnose complex problems in trees. I've come out of Murdoch Uni working on chewett decline. That was a thing that I worked on years ago, which was quite complex. And set the company up about nearly 10 years ago now, partly out of sort of short funding cycles in the uni, but partly because there was demand to come in and do this diagnostic work and then help people manage tree health, and do a lot of work in the urban space, but also plantations and native forests. So I'll talk a bit about that today. Does anyone know where this is? Absolutely. So this is just out there about 100 metres away. And this is my photo from about 5 years ago when I came in to work on a project. And I'll talk a bit about that. Okay, so this is the rail system throughout WA, and we see it's extensive. And as we know, and the image is actually up on the posters that Rachel's put together, the maps of the vegetation, they're really good because they show distinctly that this vegetation is often associated with rail corridors and roads, and we know that, so we've heard a bit about that today. But it's extensive. I want to talk a little bit about the cause of decline in vegetation condition. And it often is complex, particularly in our native trees. So it's amazing how many times people will send me a photo and ask me why their tree is dying. And I found out very early on that's a really dangerous thing to do. So because there are so many different factors. So really we have to be looking at the trees, we need to be looking at the roots, the symptoms of the tree, the body language of the tree, taking samples and so on. And this is what we call a disease decline spiral. It was developed by Paul Mannion back in the 1990s, and this is around the causes of decline in trees. So he had these three groups of factors. He had these predisposing factors, inciting factors, and contributing factors. So the predisposing factors are really the factors that, predisposing the tree to early onset of decline. So things like, even back then, talking about climate change over here, poor soil drainage, and some of these we've heard about today, salt, for example. The urban environment simply predisposes trees to early decline, the stresses that come with that. But also there were other factors like inciting factors. So these things are things that incite decline in trees. So these are trigger events. So it could be, a massive waterlogging event. It could be, a hailstorm that's come in and damaged the trees, and then diseases and pests are attracted to them. It's a trigger event. Okay, and then you get the tree, it goes into this downward decline in health, a bit like people can do, and then there are these contributing factors. Now these take the tree to a point where often it can't return, and these are other diseases and pests and borers and other things that come in. So as forest pathologists and people who diagnose these disorders, we have to consider all of these, and knowing the history of the site and where those trees grow is really, really important. So we're often just asking lots of questions, okay, and asking the farmer or asking the people who manage the site, what happened here a year ago or 5 years ago? And just driving up here today, I'm always looking at trees, and sadly I notice dead trees all the time, so I've got an eye for it, or dying trees. So I'm driving up here and I notice that the vegetation's actually looking quite healthy, and amazing how much water is around at the moment. But about 10 k's south of Mora, I noticed the trees starting to decline, and there's been a history of decline. You can see it in the trees, and I'll talk a little bit about that today. So there are all these other factors that predispose trees that aren't in this spiral, and these are ones that I've put together myself out of just experience over the last 10 years, just looking and digging up trees and being exposed to dying trees all over the world. I'm very lucky. I travel a lot with my job to some amazing places in the world. And so here, these factors, but what I wanted to point out here was this one that I've circled, and that's chemical damage, and that's the one I want to talk about today. So I can talk about other things like Phytophthora and nutritional disorders and things like that we see, but specifically today I'll talk about chemical damage. Okay, so these are my photos, okay, from about 5 years ago. So what happened was, and this happens all throughout the state, and there was mentioned a little bit today about the spraying of herbicides and the use of chemicals for controlling weeds. And sadly, I suppose what we're going to see more is if you're clearing this roadside veg and you're opening up this space to more weeds, there's going to have to be more weed spraying. It doesn't have to happen, but it will happen, okay, and that's the sad thing. What happened about 5 years ago was there was sort of weed spraying occurring along the rail corridor, and then there were these symptoms that were noticed, and it was people like Rachel that noticed them and alerted the local council, and then started to ask questions, and the farmers noticed these things, okay, and if they don't notice them, then nothing happens, and people would just accept it because they either don't see it, they don't notice it, or they just think it's part of the natural decline of trees. But these are the symptoms. So this is along the rail corridor, okay? And so you see the interesting symptoms here. So you see the trees are thinning out. Some were quite gradual, some were really quite severe, and you can see the trees, the proximity to the rail. You can see here in a rail crossing, okay? So you've got salmon gums and wandoo and York gums, a whole range of species. You've even got acacias and other species as well. So it wasn't restricted to just one species. There was quite a lot being affected. So we were brought in to diagnose the cause, and then we could see there's really interesting symptoms in the foliage. So in this case, you've got not interveinal chlorosis, because often when trees are lacking particular nutrients like iron or manganese or zinc, they'll have interveinal chlorosis. But in these trees, the veins were going yellow, which is really interesting. Okay, and it was often the older foliage, and then moving up into the young foliage, and you see the mid vein still green, but the rest of the foliage going yellow. And then if it was severe defoliation, and then resprouting, these epicormics. Okay. This is actually in the park, just over here near the tram. Okay. All right, so here again, symptoms. This is a different location. This is not Mora, this is another job that I was called out to look at. Now, rather than this being herbicides moving through the soil profile, which I'll talk a little bit about soon, this is spray drift. Okay, so this was a case where a farmer was using a helicopter to spray glyphosate, and then it was the wind, obviously a bit windy on that day, so then drifting off outside the field and then impacting the vegetation. So I was called in to determine what the cause of that was, and then basically provide evidence. And so here you see these interesting symptoms. So here you've got trees along the roadside, but on the other side, so the fields are actually over the other side of the road. And we're seeing trees that were about 100 metres away away from the field, and it was really interesting to see that, like for here, for example, the part where there was no veg, a slight gap, and then where the wind would have blown it through the gap. So it's to do with the wind direction on that time of day as well, and we saw the symptoms on the actual foliage. The actual spray droplets on the foliage as well, the pattern, and a different herbicide to what we saw before. And when severe, complete death and delamination of the bark of trees. Okay, so really quite severe in parts, and even some of the grass trees and other species. Not all of it was herbicide. Okay, so this, for example, isn't herbicide. This is a small armoured a scale insect that causes that, so which is from scale. So often finding 2 or 3 different symptoms in the same location, but definitely herbicide damage, and quite severe. Again, more examples here. Complete death of the new flush growth on young trees, and you know, right through the area where, you know, again, wind blowing through here, and then you could see the drift, young trees as well on the site. So, you know, this is not uncommon. The fact that I've been driving around the, you know, WA for the last 15 years working on tree health disorders and seeing consistently trees next to road verges dying and showing symptoms of herbicide damage. Okay, it's just consistent and being knocked back time and time again. Okay, every year, just getting a little bit affected until, you know, they're predisposed to other declines and things that cause their death over time. Okay, so this is a big issue. So in this work in through this area, so it actually extended from Moora right up to Mindanao, okay, so now Geraldton. So we were asked to first to diagnose the cause of that, and then to set up some sort of monitoring program about monitoring the change in health of the trees over time, and then treatments. So I'll show you a bit of the work we did on the treatments. But we've done, you know, again, coming out of the university in 2003 when I was first introduced to remote sensing, which is basically satellite or airborne or drone imagery. We work across all those scales. We saw the power in monitoring tree health and cover over time. So what we did was basically do a baseline survey of 50-kilometre strip of rail corridor and surrounding veg, and really precisely quantified the area of vegetation and the height classes of the vegetation as well. And this is actually running through Moora. Okay, so now you're starting to see exact area of the veg and the height classes, and we have that to the square metre on every single tree and every piece of vegetation. So now we have a baseline. So if something happens to that over time and we go again, we really precisely see what the change is over time. And that's the power in monitoring. So we're in the space of providing people and clients with real data. So using science to provide the data that they can then make informed decisions on. Not just saying we think some trees have been knocked over there, we think that patch has been, you know, affected by herbicide. This is the real data that we use. That's the cover. Okay, that's the condition. So now we're seeing we have cover, so the area of vegetation, but then we also have the condition, which is a reflectance thing. So the actual health of that vegetation. So the brighter the blue, the more reflectance. So if these, for example, are all Wandoo through here, we know that those ones that are bright blue are reflecting more highly. So it means they've got a denser crown, a greener crown, they're healthier. That's their baseline. Okay, so we have condition, we have cover. So this is the real data that we use. And this is real data from this work that we did through this area. If you zoom in a bit, now you can start to see the level of detail. Okay, so now you can see beneath that sort of 5 centimetre resolution imagery, so that's the real clear imagery that forms the base imagery, but then this is the area of the vegetation in the height classes of all those trees that sit along the rail corridor and beyond into the farms. Now we do this for whole cities, okay, so we've done this for the city of Sydney and North Sydney in November, mapped all their trees in the whole city, city of Perth, you know, Fremantle as part of the urban forest plans. We do this to help them track where the canopy is going and to set targets based on data, okay. Infill, you know, death by 1,000 cuts, the stuff we've heard about, we're tracking that all the time. Now where the suburbs are losing the canopy faster, but this is the sort of stuff that we should be doing through the wheat belt along the roads. The technology that's been used in the past by some of the, you know, might have been main roads and others is, you know, having video cameras on the front of the car, which is again really, really powerful. But, you know, you're driving around thousands of kilometres of road, someone's got to look at that and determine where the canopy is and how it's been lost, okay? So there's a huge amount of work. So this is the sort of information that's very useful. So what we did was we acquired the baseline, and then 12 months later we then flew exactly the same time of day, the same time of the year, and then looked at the change in the condition of the vegetation over that 12-month period. So this is where we can start to see if a tree's been impacted. For example, that tree there that's red, that's died or declined over 12 months. The tree's blue, it's increased in condition over that time. The little labels that you see there, they're our GPS points of trees that we've treated, okay, once we discovered the herbicide damage. We set up a big treatment program where we treated over 300 trees from here to near Geraldton in well-replicated trials to see whether we could actually bring some of these trees back, okay, because it's all cutting-edge stuff, because we were asked, right, you know now what's causing it, you know how the herbicide behaves, okay, particularly one herbicide. Is there anything we can do to try and rectify this? And so no one had ever done that work before, okay? So I then delved through the literature, see how it acted, see what might work, then said, right, we think there's an opportunity here to set up a treatment trial. No guarantees it's going to work, but let's set this up in a scientific way and see whether we can actually improve the health of some of these trees and see if we can, you know, stop them from dying. And that's what we did. And I didn't even know whether it would work, but I was hopeful. So here we see one of the herbicide-affected trees, treated 12 months later. Even I was astounded at the response in some of the trees, okay? Not always successful, so this is the importance of having replicates and controls so you can actually compare whether the treatments are effective. Not just treating 5 trees and seeing, okay, did it work? There's over 300 trees. Once we went back and reassessed those trees after 12 months, then we saw, okay, untreated, you know, decline in the condition, crown density, treated over those replicates, highly significant effect from the treatment. Okay, so great result, we're really happy. Okay, so we managed to save some of these trees over time, but there was many thousands of them that weren't treated. What was really interesting was the difference between, again, there's untreated and treated over time. But here the difference in response to the different species. So again, this is all sort of new, okay, cutting edge. No one had ever done this work on these trees before with these treatments and this problem. But, you know, things like salmon gums and wandus responded quite well. But, you know, York gums, the rough-barked eucalypts, didn't respond as well. They seemed slower to respond, so who knows? There's a whole PhD in that. Okay. But very interesting, some of the results. It wasn't restricted just to particular size classes or species. So here's your train there in the park. Okay, there's a herbicide-affected tree. Treated, came back later. I just went over there this morning actually to have a look. So that tree's about, I don't know, another half that size now. But, you know, we had some really good results in some of those trees in terms of the effect. This is I suppose the data, the numbers. Okay, so we had the numbers on the ground, the crown assessments that you've seen, but this is the numbers from the imagery. So extracting the condition data and the cover data from the pixels, and then looking at that over time. So this again, you know, treated and controlled trees. So, you know, we're looking at you know, the different classes, the categories of them. Some of them we couldn't determine because the crowns were overlapping in the imagery, so we couldn't be sure whether that was the treated tree or not, so they were undetermined. But mostly we had a really good response from the imagery as well, and then the change in condition, definite, you know, big differences between those that weren't treated and a lot of those that were treated. So it was overall, you know, a really good response. Okay, so this is a sort of final slide in the take-home messages. This first point, a lack of research and understanding around the impact of herbicides on WA native trees in our soils and our climate. Okay, so this is important because when we discovered this herbicide affecting these trees, it was moving through, the one that was moving through the soil was moving quite a long way. And the labels, nothing on the labels really talked about the effect on native trees. A lot of the work had been done in crops. A lot of the work had been done in other soil types. But no one's really done the research about these herbicides in WA soils on native trees. There's a real gap there and a lack of knowledge. So when you look at the labels, you can be applying these herbicides and they have no idea that they're being taken up and affecting the trees. The research just hasn't been done. Some of the labels also say that they should disappear within 3 to 6 months. 18 months later, we went back to the soil, tested it, and they were still there. Okay, it was in the foliage, dropping into the leaf litter. It was in the leaf litter. Okay, so this is all new. No one knows this, and we're learning all the time. Causes of decline are complex. Always, I'm always learning every job I go to, and always doing new research. Herbicide is just one, but a very important one, particularly in our environment in WA. Okay, there's a lot of herbicides applied, and the effect on native trees, I believe, it's significant. There must be much better regulation of contractors and companies. That's an absolute must. There's a lot of cowboys out there, okay? A lot of the way they're being applied is really lacks control and data. Early warning and monitoring systems are key to sustainably managing vegetation health. So I've shown you some of those, but as we've heard today, there's lots of trees being removed. There's a lack of real data there to be able to go back and say, we actually know this many trees have been removed or this many trees are being affected. The data is king, okay? It's really important. Just finally, rail reserves and road corridors in the wheat belt are incredibly important habitat, and this is a must. We must improve our approach to managing the health of those trees. So we've heard about loss, but the health of those trees, not just clearing, managing the health is really, really important. So, thanks very much.